Everybody get 3 sheets in the back, you good?
Alright, ladies and gentlemen, let's take a look at our rules here. We're going to be multiplying, and that's the only thing we're going to use these rules for is for multiplication problems. Alright, later on in the chapter we'll take a look at division, but today it's multiplication. And so the first rule we're going to take a look at is the product of power rule. Alright, to multiply powers that have the same base, and that's one thing that's important to remember, ladies and gentlemen, is that it has to be the same base. So it either has to be A's, it has to be X's, it has to be 3's. Okay, the base can be an integer value or a real number, but it has to be the same base. In order to do that, you're going to add the exponent. So the little rule they have here is a to the m times a to the n is equal to a to the m plus n. So if we take a look at it with some actual examples, we have x to the third times x to the fourth would be x to the seventh if we use that rule. And here's why, ladies and gentlemen. So if I walk past your table today and say, I don't agree with it, write it out in long form, this is what I'm going to expect you to do. X to the third means 3 x's, correct? X to the fourth means? Can you count up how many x's there are? Can we make sure we get the right exponent that way? All right, so that's why we're adding those together. So if we take a look at these examples, 5 and negative 3, they don't have any exponents on them, do they? So ladies and gentlemen, what operation do we have right here? Multiplication. So what's 5 times negative 3?
Negative 15.
Negative 15. These are not exponents, ladies and gentlemen. These are what we call coefficients. And so those coefficients don't follow this rule. They follow the rule we've always used. 5 times negative 3. Now we're looking at our A's. These are what we call the same base, A and A. Now we're going to follow that rule of adding. So how many A's do I have here?
2 A's.
3 A's. How many A's do I have here? 1. So how many total A's do I have? 4. So I'm going to call it negative 15, A to the 4th. Does that make sense, ladies and gentlemen? All right. Does it matter how many bases they give me? No, the rule is still the same. I take all my A's. So how many total A's do I have here? 4 and 1 is 5. I couldn't tell if I was hearing 5 or 9.
Hey, can I ask something?
Yes.
Why would you put that other A with that A when it's A and B's together?
They're not together. Can I write them with separate? Could I put a multiplication dot between each of those?
Yeah.
Oh, yes.
It's multiplication whether there's the dot there or whether they're side by side, correct? So we could take these and separate them. We could write the dot there, and then we can take these other ones and separate them with a multiplication symbol. So whether they put the dot there or whether they put them side by side, we keep all of our bases, all of our variables separate from each other. Okay? The same thing with this example. This is really 5 times a to the third times negative 3 times a. You can separate each of those parts with a multiplication dot. Okay? Does that make sense there, guys? That you can take that 5 and separate it as a multiplication problem separate from it? All right. So now do we see why we have 5 A's now when we pull them apart like that? How many B's do I have? 8. 5 and 3 is 8. And then 1 and 2 would give me
3.
3 C's. Tim.
You put in the middle of the A and the B and the B and the C.
You can if you want. You don't have to. Multiplication can be shown a couple of different ways. It can be shown with a dot. It can be shown with your terms right next to each other, or it could be shown with parentheses. All right? I'm trying to do as little writing as possible, so that's why I wrote my answer this way, without any dots, without any parentheses. All right? I thought I saw another hand up just a minute ago. David. Yes, this is actually what I would prefer to see, is that written out there. All right, now we're going to take a look at the power of a power. So now you have something with an exponent being raised to another exponent. So what it says here is to find that power of a power, you're going to multiply the exponents. And so if we have a to the m being raised to the n power, we're going to multiply those. M times n. So, okay. All right. So if we use that rule here, what's 3 times 4? 12. And so, ladies and gentlemen, one of the things that I use to help is to actually say what it means. This means we have x to the third 4 times, correct? Am I actually using the word times when I say that out loud? Does that help us remember our multiplication? But once again, could I write this out in long form? How many x to the thirds am I supposed to have? 4, because that's what the exponent says. So I could write out x to the third 4 times. Once you write it out that way, ladies and gentlemen, it's pretty easy to see that I'm not adding those numbers, that I am in fact multiplying them. Okay? And this was the type of problem where I went around the second hour telling most people to write it out in long form. Okay? And it's pretty easy to do. It doesn't take a whole lot of work, but it avoids a lot of wrong mistakes when you write it that way. Okay? So let's take a look at these examples. We got x to the 5th squared. That means we have x to the 5th how many times? 2 times. So how many x to the 5th do I have written down? 5 here and 5 here. So how many total is that? X to the 10th. If we need to, guys, could we write out all 5 of them? And then all 5 of those? And then count them up? You could, but we'd be really cool if we could stop right here and have those. All right? T to the 4th. How many times do we have that? 5 times. So that is t to the 20th. All right, our last rule, ladies and gentlemen, I want you guys to notice on this front side, every one of our example problems has been multiplication, correct? We have product of a power.
Sorry.
Oh, do we need to go back?
No, you're fine.
Okay.
But I just wanted to say, those of you that are careless or not really paying attention, you're really going to not like writing them out. Because if you're getting them wrong, you're really writing them out. Okay, so take your time, be patient, understand what you're doing right now, and these notes.
And what I told second hour was, guys, today's worksheet is really short. So after we grade it and I collect it tomorrow, it's going to be really easy for me to go through here and see who didn't do very well and who wasn't writing things out. And then while they're working on tomorrow's worksheet, I'm going to put a little star on the corner of the paper, and guess what a star means? You're going to no, the star means you're going to have to write it out in long form. Okay. So, well, a star I can do it all in one quick step. Okay, we'll have to debate tomorrow what we're doing there. A triangle. Okay, a triangle. Sad face. Whatever. If I put a mark on your paper, a check, an X, what about an X? Would that work for you guys? All right. That means you're going to show your work. The nice thing in 6th hour, Mr. Clem's going to be able to look through those even faster. So when he tells you to pay attention, when he tells you to listen up, when he tells you to ask questions, that's what he's referring to. All right, ladies and gentlemen, now what I have here is a product. I've got more than one term here being raised to a power. And so what that means is everything inside there has to be raised to that exponent. And you guys already knew that because we had that in our example with our warm-up, didn't we? Xy to the 3rd power. So if we take a look at this, now we have 3y. So we're dealing with an integer and a variable. So what that means is 3 has to be raised to the 4th power, and y has to be raised to the 4th power. Because we have 3y 4 times. So this isn't 3 times 4, it's 3 times 3 times 3 times 3 again, which is where that 81 is coming to. So those exponents get applied directly to those variables. You could go, or to those coefficients. So you could go to your calculator, ladies and gentlemen, and type in 3 to the 4th. Now you can't type in y to the 4th because we don't have variable values in our calculator, but we can see that we have 4 y's, and so that's where 81y to the 4th is coming from. Darlene.
So the 3 y I don't understand where you put the y.
Well, because I took 3y, and how many times did it say to write it? So 1, 2, 3, 4. So do you see the 4 3's there? So that's 3 times 3 times 3 times 3, which is the 81. How many y's do I write down? Does that make sense now? Beautiful. All right, so let's take a look at what we have here, ladies and gentlemen. We have 3x to the 3rd, y, z to the 4th. We have all of that squared, which means we have 3x to the 3rd, y, z to the 4th, times 3x to the 3rd, y, z to the 4th. If you look at that, ladies and gentlemen, and you're not sure what to do, write it out in long form. Now can we see what am I multiplying 3 by? 3. So what's 3 times 3? 9. How many x's do I have here?
2.
How many here?
Oh, sorry, 3.
3 and
3.
3 more, so that's x to the
6.
6. How many y's do I have, Damien? This is where it gets a little tricky, guys. This is 1 y and this is 1 y, correct? So how many total y's do I have?
2.
And how many total z's do I have?
2.
So how many here?
8.
4, and 4 is
8. I have a question.
yes.
For the second one, for the R, S 3, and then 3 back. So wouldn't it just be? So wouldn't you just add the 4 and the 3 and the 5 together?
No.
I mean, multiply together.
I don't want to say yes to that, because I don't think so. Well, I don't have to, but I'm going to guess that some of you might benefit from it the first time. So we're going to have r to the 4, s to the 3rd, t, r to the 4th, s to the 3rd, t, r to the 4th, s to the 3rd, t. Now here's what I told second hour. You may have run out of room here, guys, but it's still just multiplication. So write it down here in this line. r to the 4th, s to the 3rd, t,
Oh,
r to the 4th, s to the 3rd, t. All right, show your 5 combinations. Now we know what we're doing. I'm not multiplying all of those numbers together. I'm not multiplying all of those. But how many arts do I have? I've got 4, and then 4 more, and 4 more, and 4 more, and 4 more. So either do 4 plus 4 plus 4 plus 4 plus 4, or do 4 times 5. So that's going to give you r to the 20th. We have s to the 3rd, yeah. 5 times s to the 15th.
Oh, 15, my bad. I was trying to do something.
How many t's do I have? 4. Well, be careful. I've got 1, 2, 3, 4,
So that's 5.
t to the 5th. Chandler.
Oh, okay, so when do you build like grading between like the grading between R20 and 5? That's like multiplication.
It's always multiplication. Yeah, but there's no multiplication is the only operation I can write down without a symbol. Division needs a fraction line, addition needs a plus, subtraction needs a minus, right? So multiplication is the only thing that we can write down without a symbol.
You're not getting this right.
Ladies and gentlemen, on the back side, there are 5 on your own. You need to get going with those. In about 3 minutes, I'm going to randomly pick names, and we're going to come up to the front to do those problems.